Well, dear ladies and gentlemen, now that we've heard about local PCA, Oculus, FOSI, cache, and Huff, a lot about Huff transform, if you recall, there was one slide where we had this tree of all these different methods. And there we asked, do we really need to go through all these methods, to all these algorithms with all the details? And the answer was no, it's perfectly sufficient if we take a handful of them, which we did, like Oculus, local PCA, 4C, cache, 4, that's not even a handful, but it's still a lot. And we said no, because it's more important, at least more important to me, that you try to get like the higher level concepts or like the taxonomy or categories. And here you have one slide, which is kind of like a summary. You have like different types of methods like bottom-up search, and there you have something like click and subclue, which is access parallel from the subspace clustering, projected clustering, a top-down approach, or correlation clustering as top-down approach like Oculus 4C and cache. So what you see on that one particular of like recap slide, you have distinctions between bottom-up versus top-down, or cluster-based versus instance-based, or PCA-based versus Huff-based. But is this really the only way that we can classify or say categorize the different algorithms? And the answer to that is no, it is not. And in the upcoming slides, I'm going to introduce you different taxonomies that other people have already done, smart people did in their papers. One example here is a work by Professor Hans-Peter Krekel, Professor Per Kröger, and Professor Arthur Zimek, Clustering High-Dimensional Data. It's a survey, it's a formidable survey they've written that goes through all the different types like subspace clustering, projected clustering, bisection, bi-clustering, and correlation clustering. And there, for instance, something that we extracted is they have this specific taxonomy based on these following aspects. So they say, is in this concrete case of arbitrary-oriented subspace clustering, is it relying on the locality assumption, yes or no? Does it have an adaptive density threshold, or is it a static fixed one for all objects? Is it independent with respect to the order of features? So it makes a difference if I start with X and then Y and Z, or Z and then X, Y. Is it robust towards noise? We shall see that, for instance, Oculus and local PCA are absolutely not robust towards noise because they have no noise or outlier detection at all. Are they independent with respect to the order of objects? So does it make a difference if I add the first point and then the third one, or first the third one and then the first? Are they deterministic? Will I always get the same results? Or is it possible that I get totally different results? In case of Oculus, for instance, or local PCA, since you are randomly seeding the centroids, you may get totally different results. So Oculus, for instance, is inherently non-deterministic. Is it capable to detect arbitrary number of clusters? So can I say, okay, detect, find me 5 clusters, find me 10, or can't I control that? Is it capable of detecting hierarchical structures? So detecting like a line on a plane on a cube, and so on and so forth. Has it the capability of detecting overlapping clusters or subspaces? And does it have the capability to detect complex correlations? So all these different features that you see here, or all these different aspects, is what they consider as important, as something to follow and or to categorize with. And they have in their work like formidable elaboration with huge, massive tables with all of these different aspects as columns, and then a checkbox if that particular algorithm satisfies the property or not. So I strongly recommend you to check out, if you have time, this particular paper here from this ACM Transactions on Knowledge Discovery from Data TKDD journal. You see, it's already like over 12 years old, but nonetheless, it's a pioneering work. So they did something at that time. They said, we have plenty of algorithms. Now we need some kind of systemic into it. However, this is like one view or one specific taxonomy they introduced, these authors here. Different authors from different domains, like Weidel, also introduced a paper called Subspace Clustering in the IEEE Signal Processing magazine. And there Vital introduced a totally different taxonomy. They do not call it arbitrary-oriented subspace clustering, and especially not correlation clustering. They call it in general subspace clustering. So Vital is one scientist that is from the domain of computer vision, also famous. And what here is done, it has a different categorization, like what are the underlying techniques? What is it based for? So there we got a classification into like algebraic methods, like matrix factorization based algorithms or generalization of PCA, iterative methods like case subspaces, for instance, what we have like oracles and such, they're iterative. With each iteration, it starts to find better and better and better, or to build up the clustering. Then we've got statistical methods like, for instance, random sample consensus, known as RANSAC, or spectral clustering based methods. So local linear manifold clustering or sparse subspace clustering, low rank representation, and so on. So here you have like different categorization, different taxonomy, algebraic, iterative, statistical, and spectral based. Also here, one can of course dispute and say, is this like a good categorization or not? However, it's, so to speak, dangerous to say it's good or bad, but what is more suitable for your specific case. And we or also in context of dissertation, I ask myself, like, what is a different representation, or what is the focus that we wish to set on? And so we came up in this third taxonomy with 4 aspects, like distance functions, how are similarities or dissimilarities between objects or subspaces computed, hyperparameters, which properties of the clustering can be controlled, number of clusters, the density of the clusters, the deviation or the amount of noise it contains, and so on and so forth. The view, so what views are supported? Is it a local cluster? Is it like global cluster that detects like 2 local patches as one common cluster? And what is the objective function? So towards which objective or goal are the resulting clusters optimized? And you see, it's the taxonomy we introduced here with these 4 aspects, they are more of like result oriented, like resulting cluster. Also the view is something in the result that you see what has been detected as local or global. Also distances, like all the distances in such a way that it detects like more compact clusters around the line or not. So these 4 aspects here are highly tailored towards the outcome. So we are asking a change in distance function or hyperparameters or view or the objective function. How does that affect the resulting cluster that we see in the end? And so we will go now through the upcoming 4 videos then through each of these aspects, elaborate on them. Just as a kind of like warning, you may see a lot of math. Don't get scared. Let's say, oh my goodness, what is this hell of formulas now getting in here? It's less important, or it's not important, or so to speak, in extreme cases to me, that you know these formulas, but the text, like what is the meaning? What can we observe? This is what matters most to me in this case. And with these words, take care and see you in the next video about the distance functions.